It was only a matter of time before someone else took the lead in the race for solid-state batteries, and it seems BYD got there first. The Chinese company, which had already been attracting attention with its Blade battery, has now decided to double down. The brand's new prototype promises a quantum leap in autonomy and recharge time, two of the biggest Achilles heels of current electric cars. Just imagine, up to 900 miles of autonomy with a charge of just 12 minutes. This is not just a technical advance, it is almost a direct provocation to Tesla. And Elon Musk is certainly paying attention. The battery, which is being tested in the BYD Seal model, could be the game-changer that the market has been waiting for years. If everything that was promised is actually delivered, we are facing a new level for electric vehicles. The most impressive thing is that, unlike many announcements that remain only in PowerPoint, this technology has already come to fruition. Pilot production is already underway, and testing on real vehicles is happening right now. In other words, this is not just laboratory talk, it is really happening. The curious thing is that, until recently, when people talked about solid-state batteries, most people turned up their noses. They were seen as a distant dream, almost like automotive science fiction. But BYD managed to build a working prototype and, from what is being reported, it has truly surprising performance. The question now is how this will impact the market, and especially how competitors will react. Will Tesla, known for leading innovation, swallow this delay? In fact, there is one detail that many people underestimate. China already dominates a large part of the battery supply chain. BYD not only manufactures, but also controls several stages of production, which gives the company a huge strategic advantage. With this new battery model, they are not just innovating, they are dictating the rules of the game. And while many are still debating whether the technology will really catch on, BYD is already accelerating. The immediate impact, of course, is the pressure this creates on other manufacturers. If BYD can get this type of battery on the road before anyone else, it could gain a huge share of the global market. After all, who wouldn't want an electric car that charges in 12 minutes and can travel almost 1,500 kilometers? Consumers are eager for something like this, and automakers know it. That's why BYD's move is being taken so seriously. Another interesting point is the timing. BYD chose a perfect moment to launch this prototype, when the EV market is maturing and criticism about range and recharge time is still very strong. It's as if they listened to all the complaints and said, "Okay, now let's deal with this one." And they did. With the Seal model, which is already competitive, they managed to incorporate cutting-edge technology that promises to change everything, from the way we drive to the way we plan trips. The secret to this revolution lies in something that many people ignore: replacing the liquid electrolyte with a solid one. It may seem like a technical detail, but this substitution changes everything. In traditional batteries, the liquid electrolyte is unstable, flammable, and prone to leaks. The solid electrolyte, made of oxides or sulfides, is like replacing gasoline with water in terms of fire risk. This not only increases safety, but also allows for a much more efficient increase in energy density. And when we talk about energy density, we are directly talking about autonomy. BYD has managed to achieve 400 kWh with this new battery, almost double the current batteries used by Tesla. And this isn't just a pretty number on paper. It's what defines how many kilometers a car can travel with the same amount of charge. This improvement allows for lighter, more powerful vehicles with much greater range, which completely changes the experience of driving an electric car. It's like going from a budget car to a luxury model without changing the engine, just with a smarter battery. The coolest thing is that all this comes without sacrificing safety. On the contrary, solid batteries are known for their better resistance to impacts, punctures, and extreme temperatures. With solid electrolytes, there is no risk of fire spreading like there is with liquid cells. This means that even in severe collisions, the chances of explosion or fire are almost zero. For those who were still afraid of electric cars, this type of technology could be the argument they needed to change their minds. Another interesting point is how this affects the battery's lifespan. The solid electrolyte reduces internal wear and tear on the cells, reducing the risk of dendrite formation, those lithium structures that cause short circuits and gradually kill the battery. This significantly increases battery life. We're talking about batteries that can last 20 years or more, with minimal loss of capacity. This even changes the used battery market, which is still an unknown quantity in the EV universe today. And there's more. With higher energy density and less risk of overheating, solid-state batteries can operate under higher loads. This opens the door to ultra-fast charging systems, such as those BYD is testing. The combination of solid electrolyte and high-purity materials allows for much more efficient ion conduction, which means shorter recharges without compromising the integrity of the cell. It's a hard-to-beat combo. More range, more safety, and more speed. Of course, we can't talk about technology without mentioning practicality. Replacing liquid electrolytes with solid ones also makes battery design easier. They can be more compact, have different shapes, and take up less space in the vehicle. This frees up interior space, improves weight distribution, and can even open up possibilities for new car concepts. It's not just about going further. It's about reinventing the way cars are built on the inside. Now that the world is starting to digest the initial shock caused by BYD, the details surrounding autonomy and energy efficiency are attracting even more attention. The number that has been circulating the most is practically unbelievable: 932 miles with just 12 minutes of charging. That's right, less time than it takes to get a coffee, and you would already have autonomy to cross more than half a continent. And if the battery is fully charged, this range can reach 165 miles, according to the CLTC standard. The first reaction of many people was to doubt, and rightly so. But the tests are happening with real vehicles, not just in the laboratory. The magic behind this incredible performance lies in the combination of energy density and accelerated charging capacity. With 400 kWh, the battery can store more energy without adding extra weight, which already improves performance. But the real leap forward is in the full use of energy. Less dispersion, less heat, and a much higher transfer efficiency than in traditional batteries. This completely changes the conversation about autonomy and especially about recharging. Now, imagine this applied to an everyday car. With a battery pack of just 60 kilowatts, the vehicle can reach up to 621 miles of autonomy. That's the equivalent of driving for days without worrying about finding a charger. For those who still associate electric cars with range anxiety, this technology will put an end to that problem once and for all. And if consumers have access to 1,000 kilowatt chargers, like the ones BYD is already starting to implement, then the revolution is complete. We also cannot ignore the impact on urban mobility and even road transport. With batteries that offer this kind of range and such fast charging, even electric trucks and buses are starting to make more economic sense. Recharging stops are no longer a logistical problem and are now shorter than a driver's normal intervals. Infrastructure is keeping pace with this evolution, and the use of fossil fuel-powered vehicles is becoming increasingly difficult to justify. Another interesting factor in this story is that BYD is being conservative in its testing. They are not boasting about the highest possible capacities, but rather the most stable and realistic ones. They preferred to work with solid and achievable targets to ensure that mass production is viable. This gives even more credibility to the numbers. Unlike startups that promise the world and disappear halfway through, BYD is treading firmly and has already shown that it knows how to scale technology efficiently. There is a technical detail that also makes all the difference. The use of materials such as ultrafine compound oxides in the electrolyte, together with high-capacity cathodes and anodes, provides superior ionic and electronic conductivity, which directly contributes to this absurd autonomy performance. In other words, Electrons and ions move more freely and quickly within the cell, which means less resistance, less heat, and more energy is used. All this without compromising the integrity of the battery. With so much exciting stuff happening on the technology front, it's easy to forget that there are still huge hurdles ahead. And the biggest one is cost. Solid-state batteries, as promising as they are, still cost 2 to 4 times more than conventional lithium-ion batteries. This isn't just a matter of price per pound or per cell. It's a matter of rare materials, controlled environments, and manufacturing processes that more closely resemble those of the semiconductor industry than those of the automotive industry. The production of these batteries requires 100% moisture-free environments, with temperature control and near-absolute purity. We are talking about clean rooms with standards similar to those used to manufacture computer processors. In addition, the materials that make up the solid electrolytes, such as sulfides and glassy oxides, are extremely sensitive to handling and humidity in the air. This means that BYD, if it wants to scale this technology, will have to build new production lines from scratch, completely different from those used for current Blade LFP batteries. Another huge challenge is manufacturing yield. While LFP battery production reaches yields of 95% to 98%, in solid-state batteries, this figure barely reaches 70% in many cases. In other words, out of every 100 batteries produced, around 30 may come out with some type of failure. This generates waste, makes the process more expensive, and slows down scalability even more. Even with all of BYD's know-how, optimizing this yield will take time, and time costs money, especially when you're racing against the market and global expectations. The materials are also expensive. To achieve the desired performance levels, BYD is using lithium metal or silicon carbon anodes, both of which are expensive and have very specific technical requirements. Not to mention the high-purity composite electrolytes, which need to be treated with advanced pressing and sintering techniques. All of this directly affects the final cost of the battery, which ends up being out of reach for the average consumer, at least for now. And as if that weren't enough, there's a logistical hurdle. Current factories simply aren't suited for this type of production. You can't adapt a traditional battery assembly line to make solid-state batteries. You have to invest in new buildings, new equipment, and new quality control technologies. It's almost like setting up a new company within the company. And that's where the most critical issue comes in. The investment required for this is huge, and the return on investment is still uncertain. Still, BYD is betting big. Limited production is expected to begin in 2027, which would give it enough time to validate performance in real use and fix any issues before scaling up in 2028. The company seems to be playing it safe, prioritizing stability and reliability over rushing through the market. And honestly, that's a smart choice. Better to make sure the product works perfectly before trying to put millions of units on the road. While BYD is accelerating full steam ahead in this new era of solid-state batteries, Tesla, curiously, has yet to officially enter the race. This comes as a bit of a surprise. After all, Elon Musk has always been synonymous with innovation and technological disruption. But for now, the American giant continues to bet heavily on 4680 cells, which are an evolution of lithium-ion batteries and promise gains in efficiency and cost, but still don't come close to the absurd numbers that BYD is putting on the table with the new solid-state cells. It's important to understand why Tesla is still on the sidelines. The main reason, analysts say, is cost and scale. The company has invested billions in factories optimized to mass-produce the 4680s and changing course now to a technology that is still expensive and full of technical challenges would require not only a complete industrial restructuring, but also a change in strategy. And Elon Musk doesn't usually take such big steps without first squeezing every last drop of efficiency out of current technologies. Does that make sense? It does. But it also shows that, this time, someone got ahead of the game. Still, It's worth remembering that Tesla isn't completely unaware of what BYD is doing. In fact, it already uses the Chinese company's blade batteries in its Berlin-built Model Ys. This partnership isn't a mere detail. It's a subtle admission that BYD has plenty of know-how when it comes to safe and efficient batteries. Maybe Elon is watching from afar, waiting for the right moment to get into the solid-state battery game. Maybe he's waiting for costs to come down. Or maybe, as he often does, he's quietly cooking something up. But while Tesla is thinking, the market is moving. The risk for Musk is that his competitors will gain valuable territory in an industry he helped shape. BYD's monstrous range and near-instantaneous charging times are arguments that make any consumer's eyes light up. And even though Tesla has the most robust supercharger network in the world, the idea of charging a car in 12 minutes, or even less in Samsung's case, is hard to compete with just good intentions and promises for the future. And speaking of the charging network, it is a huge asset for Tesla. The company's infrastructure is still one of Musk's biggest competitive advantages. The Supercharger V3 and future V4 chargers guarantee fast and reliable charging, which still keeps the brand's cars as a benchmark in practicality. But the problem is that, as other automakers, like BYD itself, start installing 1,000 kW networks, this advantage could start to disappear. And quickly. While Tesla is watching, Samsung has decided to step on the gas. In a discreet manner, without the typical fanfare of spectacular announcements, the South Korean giant has already put its pilot production line for solid-state batteries into operation and, surprisingly, has already sent working prototypes to major automakers. This is no small feat. We are talking about batteries that reach 500 Wh of energy density, surpassing even BYD's impressive 400 Wh. And with this, the promise is not just more autonomy. It is a leap in the way we see the future of electric vehicles. Samsung isn't just trying to compete, it's aiming squarely for the lead, with clear goals and robust technology. Its prototypes allow for a range of up to 621 miles on a single charge, and the recharge time is even more aggressive, just 9 minutes to reach 80% battery. That's less time than you'd expect to spend at an airport cafe. And all of this comes with an even bolder promise: a battery life cycle of up to 20 years, something that, if confirmed, would completely redefine the idea of maintenance in electric vehicles. Samsung's technical difference lies in the cell's internal architecture. The company has completely eliminated the traditional metal anode, replacing it with a silicon-carbon composite, which reduces the cell's volume and dramatically increases storage capacity. This change not only saves space, but also improves the battery's thermal stability and overall safety. The proprietary solid electrolyte, made with advanced ceramics and high-conductivity glasses, enables extremely efficient ion conduction and reduces the risk of dendrite formation. This means that, unlike conventional batteries, Samsung's batteries don't have to worry about overheating, leaking, or exploding. The absence of flammable liquids solves one of the biggest headaches in the EV industry. And with that, more compact, lighter, and safer models become viable. Can you imagine an electric city hatchback with over 600 miles of range? Well, that's exactly the kind of scenario that the company wants to make a reality in the coming years, starting with premium models and gradually moving down to mid-range models. Despite its enthusiasm, Samsung does not hide the fact that the challenges are still enormous. The materials used in the ceramic electrolyte and in the interfaces between the electrodes require manufacturing under extremely controlled conditions, which makes production more expensive. Quite expensive, by the way. Therefore, the company's strategy is to start with luxury vehicles, where costs are more tolerable, and gradually optimize the process as demand grows and the technology matures. A plan that, frankly, seems very well thought out. With the bold steps taken by BYD and Samsung, the market is beginning to realize that we are entering a new era of electric vehicles. Promises that for so long seemed distant are beginning to take shape, and what was once a cause for skepticism is now arousing an almost childish anxiety on the part of consumers. After all, we are not talking about just incremental improvements, but a true technological leap that could redefine everything we know about automotive batteries by 2030. For years, electric cars were seen as a viable but limited alternative. The issues of range, recharging time, and the risk of overheating or fire still lingered like persistent ghosts. But with solid-state batteries, all that is starting to change radically. What is being promised, and in many cases already demonstrated, is the possibility of driving 600, 800, or even 1,000 miles on a single charge, and recharging the car in less than 10 minutes. This is not just evolution. It is almost a quiet revolution that is about to explode. The difference this time is that the big players are taking it seriously. The battery race has gone from being just a laboratory experiment to a large-scale industrial battle. And the most interesting thing is that it's not just automakers that are competing. Technology companies like Samsung are investing their bets in this transformation with the same enthusiasm they had when launching revolutionary smartphones and chips. This is a clear sign that the battle for the car of the future will not only be fought on the roads, it will also take place in laboratories and factories around the world.